Hi, Cougars. Okay, yesterday we started working on the distributive property and we learned how to share our outside number to all the things on the inside, the terms on the inside of the parentheses. And so today what we're going to do is we're going to finish up our success criteria by being able to answer this question of how do we use the distributive property to combine like terms. So we're going to use our distributive property to combine like terms. So first of all, we need to talk about this word like terms. So like terms is our vocab word for today. Like terms. Okay. Well, in an algebraic expression, we know that terms are the different parts, like the constants, the coefficients, and the variables that make up the expression, that make up the sentence. So like terms are the things that are the same. Okay, so they are the terms that have the same variables or are raised to the same powers or have the same, or are just constants. So like terms are terms that have the same variables are raised to the same powers, or exponents, I mean, or are constants. So they need to be similar. The key word here is same. Okay, so like terms are the same. They are terms that are the same. Terms that are the same. Not as in the same number, but they're similar in if it has an X and an X, it'll go together. If it's a Y and a Y, it'll go together. If it's a 2Y and a 3, those will not go together. And we'll see how that works in just a second. So it's really important for us to put things together that are the same. So, for example, if I had an expression that looked like this one, let's do an example. Example A. If I had 5x plus 2x plus 2 plus 19, the things that are the same can go together. We would put the things that are the same in the same category. This 5x and this 2x are the same because they both have x's. This 2 and this 19 go together because they're both constants. They're both numbers, so they can go together. So we would be able to combine these like terms and these like terms together. So 5 plus 2 gives us 7 x's. So that means that we would have 7 x's here. And over here, we would have 2 and 19. So if we added those, because they're both positives, we would have 21. So when we simplify this expression or combine our like terms, we have 7x plus 21. We cannot put this x with this 21 because this 21 does not have an x. This is a constant. And this is a coefficient. And coefficients and constants cannot go together. Okay, they are part of two different clubs. They cannot be in the same club. Okay, let's try another one. So I have 3x plus 9 plus 2x minus 5. Okay, notice up above that I circled the symbol with the operation with the number that it was in front of. It's really important to do that because what happens is this operation becomes part of this coefficient or this constant. It becomes part of the term. This is a positive 5, this is a positive 2, this is a positive 2, and this is a positive 19. When you get into 7th grade, we're going to teach you that there is no such thing as subtraction. I know, math. Go figure. Okay, but for now, just stick with me and you'll be really, really happy that you've started to circle the symbol with the letter, or with the operation with the term. That's what I mean. The operation with the term, so that way you have it together so you know if it's a positive number or a negative number. Okay, so first, let's go through and let's circle all the things that are the same. So this 3x, do we have any more x's? Yes, this 2x right here, and it's a positive 2x. So let's circle the positive sign with it. Notice it's the sign that's in front. This doesn't have a sign in front, but it's still a positive number because it does not have a negative sign in front of it. All right, I now have constants to circle. This is a positive 9, and here I have a minus 5, which also is a negative 5. Now, the reason why we want to subtract that negative sign with that 5 is because when we rewrite this, we're going to use the commutative property to move our numbers around because we want to put our terms that are the same together. We need to be able to combine these. So we're going to look back at our commutative property here, and we're going to look at commutative property, and it says that I can move things together that are the same, right? So if it's a positive number, I can move it around. So I can move positive things around. Let's move them. I'm going to move this positive 2x to be with this 3x. So let's move that so we can combine these two things together. I can also move this 9 so that it is with this negative 5. I'm just going to leave that negative 5 right there. So let's start moving some stuff. All right, pack your bags, coefficients, you're moving. All right, so we have 3x right here. I'm going to check that guy off because I wrote him down. And I have positive 2x, so plus 2x. I'm going to check that one off because I wrote it down. Now, I'm checking them off because I've moved them around, and if this list were longer, I want to make sure I didn't forget any numbers. Now I have positive 9. So I'm going to write positive 9 and done. Then I have to drop down my negative 5. Done. Okay, now I'm ready to combine like terms. I'm ready to put together the things that are the same. My greens can go together, my pinks can go together. So all the x's together, all the constants together. 3 plus 2 is 5, so that tells me I have 5 x's. And now over here, I have 9 minus 5. So 9 minus 5. That's why it was really important to bring that subtraction sign down. 9 minus 5 is 4. Now, is that a positive 4 or a or negative 4? Well, it's a positive 4, so I'm going to write positive 4 or plus 4. So I have 5x plus 4. This is done. I have simplified this expression because x and 4 cannot go together. This constant cannot be combined with this coefficient. It is done. Okay, let's look at another problem. Let's look at what happens when you have, oh, this is a fantastic problem. Okay, let's look at this one. I have y plus y plus y. Y plus y plus y. Well, here, all I have are y's. So I am just going to combine. Oh, I did it. Messed up. Do not forget your positive sign. I am just going to combine all of my y's. Now, there is no number in front of these. Whatever will I do? Okay, well, don't fret. Do not freak out because this is not a problem. Because you see, this is actually 1y. This is 2y's, and this is 3y's, right? So the 1 is just invisible. So we're just going to add a 1 in front of it. You see, I've told you this secret before. Mathematicians are super lazy. We don't like to write everything out. So if I don't have to put a 1 in front of this y, why would I? Right? So a mathematician is not going to put a 1 in front of a y because if there's just one y by itself, we already know it's just one y. So this is kind of redundant, right? So really, we don't need this 1, but we're going to put it here as a placeholder. So this is the same as saying 1y, 2y's, and 3y's. So this means that I have 3 y's, or I have 3y, 3 times y. That is all that you do. So when you have one letter by itself, it's just one letter. Okay, and let's do one last thing, and then I'm going to give you a try it. Okay, this one right here, 7z plus, let's throw in the distributive property, 2 times z minus 5. Okay, order of operations is coming back right now. We know we need to start in the parentheses, but we can't do anything in the parentheses because z's cannot go with constants. So our job then is to just multiply. So we're going to go back to what we learned yesterday, and we're going to share and care. Share and care. So we're going to share and care. Okay, so share, then care. We're going to take this 2, and we're going to share it with the z. 2 times z gives us 2z. 2 times 5 gives us 2 times 5. We have to put our minus sign in there. Or you could have just written 10 if you can do that right away. Now I'm going to drop down the rest of this problem. Just should have written that in pink though. I'll rewrite it in pink. Okay, so 7z plus 2z minus 10. Okay, because I multiplied those two together. Now let's combine like terms. 7 plus 2, because those both have z's on them. 7 plus 2 is 9z minus 10. So really, if I were to cover this part of the problem up, I could have started with distributive property, did that, did the distributive property, and then I could have just dropped down this 7z and then added it in. This, because it's on the outside of the parentheses, does not matter. Okay, it is your turn for a try it. All right, please try this one. I would like for you to simplify this expression. It is try it number 5 in your book or online book. 8 plus 3z minus z. Apparently this chapter loves z's. And who doesn't? I mean, z all over the place, right? Z, Z, Z. Lots of sleep. That's what we need right now. Lots and lots of sleep. Okay, hit pause, or you're going to hear me solve this and you don't want to hear that right now. So hit pause so you can check your own understanding. All right, so I know that this is a 1z. Not like a baby onesie, but like a 1z. Okay, and I need to combine my like terms like this, circle that and that. I'm going to drop down my 8. Okay, so I have 3 minus 1, which gives me 2 z's. So 8 plus 2 z's. So my grand total is 8 plus 2z. 8 plus 2z, because 3 minus 1z, 3 z's minus 1 z's means I lost a z of sleep. That's never good. Okay, how did you do on that? How did you do? All right, now come on over here and answer your essential question. How do we use the distributive property to combine like terms? Answer that question for me, the one that was at the very beginning of the section. How did we use the distributive model to combine like terms? How do we combine like terms? What do we do? And then put your rating in the box. 1, I don't know how to put terms together. No idea. 2, I'm okay. I just need some more practice. 3, I love this. This is fantastic. I am fabulous at this. I know you all love this so much. Okay, and when you're done, head on over to practice. If you need help, you better be stopping in and asking for help. Please, stop in and ask for help. I can't help you if you don't ask me for help. I am not a mind reader. All right, otherwise, make it a great day the Cougar way.